Let's see another problem from LeetCode. This is largest rectangle in histogram, and we'll see the code. Code is a little bit lengthy, but once you have like clear idea how we'll solve, then it makes sense and it seems easy then. Yeah. So first, try to understand this problem, and there are two other problems here also. I have opened here. I have already created the video on that, so that's so we'll see that also, because all these three problems look similar, but there are some differences and we need to find out. So let's understand this problem, then we'll see another trapping rainwater and then container with most water. We'll see that, and then we're going to come back and try to see how we'll solve this. So in this problem, if you see this height, so each height, this is the height 2 1, and the width of each block is 1 here. So if I say 2 and 1, and if you see like what is the difference between 2 and 1, then in this case 2 and 1, then here like from this to this distance, so we cannot say okay that's just a 1 distance, because width is 1 for this, and this width is also 1, so 1 1 2. Anyway, so in this problem what it's saying, find the largest rectangle. So if you see the rectangle here, from here we cannot consider this one, but from here we can consider this is a rectangle, like this till here it's a rectangle. So if you see the height is 1, but what is the this width? So 1 2 3 4 5 6, so 6 into 1 6. So this rectangle is the sixth. So, and if you see this one, so area of this rectangle, if you see the 5 and 6, this is 2, width is 2, and the 5 and 5 here, 5 into 2 10. So that's the largest rectangle, so we need to find out that one. So we need to check each rectangle here, and whatever the rectangle you see, and you need to return the largest rectangle, and in this example this is the largest rectangle. Okay, so at least we understood this problem. Let's see, there is another similar problem here. So this is trapping rainwater. So in this problem also, if you see, there is a height here, and in this here also each bar is 1, so each bar is 1. But in this case, if you see the 0, so like you can consider there is a no building here, and 1, there is a 1 building, there's nothing here. 2 is two story building, 2 floor, just consider 1 floor here. And in this case we need to find out the how much unit of water we can save. Like if there's a building, this building, then the water can come here, so we can calculate this as a 1 unit, 1 2 unit, this is 2, again this is 1, and we need to return that. So this is another problem here. If you see the container with most water, in this problem, if you see, again this is the height, and then in this height, this is all the height, and we need to find out there's a container, like if you start from here and here, so this is the biggest container, that's where the most water we can save. So there is a difference in this problem and this problem. So if you consider from here to here, maybe that can be one container, but this is not the problem with the container, this is the largest rectangle. So we need to consider the adjacent one, and from here if you see there is a empty, so we cannot consider this. 5 6. I can take this is a largest rectangle. So anyway, you can check out this video also and you'll get some idea, but I'll just tell you a little bit about how I solved this thing. So in this problem, I just calculated the left wall here. You can get the detail later here, you can see that. But anyway, this is the one height array. I created the similar length of the array called left and the right. So I created some concept of left wall and right wall, and I see here that's a length is 0. This one, the left wall length is 1. If it's 2, and here I'll consider also 2 because that's the biggest one. Again here I consider 2, and this one 3. And again the same way I'll try to fill the right wall, so left wall and the right wall, and then the logic will be the minimum of left and right wall, and then hyphen minus height. So that's the logic here, but I have explained that detail here. You can get the idea. In this example, if you want to find out what is the container with the most water, then in this example what I have tried here is I'll just fix the 2 pointer, and maybe in this example let's say 1 pointer is here, 1 pointer is here, and I'll see what is the minimum one, and then that is the height, minimum height into width. So that's the area, and in that way I'll try to find out the max area. So again I check, okay, which is the smaller. If this is the smaller, then or this is a smaller, then I'll come here. If this is a smaller, then I'll come here, and in this way I will just find the area. But again, you can check out this video and you'll get the better idea once you see watch the whole video. But okay, come back to this problem. In this problem, we need to find out the largest rectangle in a histogram. So how to find this largest rectangle? So there is a in this example I have explained this commented code. If you see, that's a brute force way. I'm just solving this, and in a brute force way there is a one outer for loop and there are 2 inner for loops inside this. So here what I do, like let's say I will start from here, and if I see if any this wall, or I can say any height that is bigger than this, then I can move this side, and if not, then I'll not move, I'll just be here. And from here I see the right side, and if I see any height is bigger or equal to this, then I'll move to this side. So this, so left pointer is here because I cannot move here, left side, and from here right pointer I cannot move again here, the right side, like I'll be here. And then so that's what I'm doing. So one is a outer for loop. From here I just fix left and right I, and then from any point, I'm just checking if the height left is greater than height I. If that is the case, then I'll move the left side, or I can check the heights right is greater than heights I, so I'll move to the right side. So that's the logic here I have put. That's a brute force, and then I've just calculated the area, right I minus left I minus 1 into heights I. So that's a simple logic I have put this thing, but this is not the expected answer. So anyway, this logic is very easy, like from any point just go to the left, go to the right, and then add this logic and you get the area. But if you try to find most efficient solution, then we'll see the example here. So for the most efficient solution, we need to find the calculate the previous smallest element. So like let's say example, this is the bigger example. I'm just taking one smaller example, 3 to 4, 3 to 4, and here I'm checking like first point, like calculate previous smallest element. So from 3, what is the previous smallest element? So there is nothing, then I'll just put the -1 in a left. Again I'll come at 2 and check what is the previous smallest element. So there is nothing smallest, then I'll put -1. I'll check for 4 what is the previous smallest. For 2 is previous smallest. So for 2 I put the index here. For the 2, that's a 1 index, so I put the index 1. In the similar way, I will start from right to left, and I'll check what is the next smallest element. So here there is nothing next element, so in that case I'll just put the length. So length of this height is 3, 1 to 3. There are 3 items, so I just put 3. From the 2, what is the next smallest element? So here there's nothing, then I will put the height of the or this length of this height, this 3, 1 to 3, and then I'll come to this place, and what is the next smallest element? That's a 2. So index for this 2 is 1, so I just put the 1. So in this way, I calculate left and right. So left array contains that's index of the smallest element in the left side, right contains index of the smallest element in the right side. And once we have this, then we'll have the formula. What we do, we'll see the right. So we'll have one loop, and we'll iterate loop I 0 to length of this height, and I'll check the right I. So this 1 minus 1, so 1 minus 1, so the plus, it becomes plus. So 2, and again 2, and then there's a one additional thing, minus 1. So 1 and into 3, 3. So we'll do exactly this kind of logic. So here if I see 3 minus 1, 4, and minus 1, 3, right? A 3 minus 1 is a 4, and 4 minus, so 3 minus 1, that becomes 4, because minus minus plus 4, and minus 1, so 3 into 2, 6. In the similar way, 3 minus 1, 2, 3 minus 1, 2, and minus 1, 1 into 4, 4. So this 6 is, 6 is the max area. So if you do in this way, there will be 3 paths, but the solution will be order of n. So that's what we are going to see, the logic for that. So that's why I added the logic. The previous smallest element, I pass the heights, and this is another array that gives me this value. And then next smallest element, I pass the heights, and this gives this value. And then I call the find max area, where I pass this array, and the heights, and added the logic like this, and that returns the max area. So here you just try to understand this, how to find the previous smallest element, and then there will be a little bit trick to find the right smallest or next smallest element. So we'll see that. So finding and if you find the previous, if you are good with this logic, then this is very simple. So here in this example, let's see, this previous previous smallest element. So how I did, there is a result, that's what I'm going to return, where I'm going to fill this the value. I created a stack, and there is a one loop, it starts from 0. and then this for loop, there is a one internal for loop, will not come here, just directly jump to this place first. I will write this code and I will check whether this stack length is 0. So in the beginning, there is nothing. I will be 0 and will be at the first place here, and we're trying to find out what is the left smallest element. There is nothing, so -1. So that's why I'm checking. Okay, stack length 0, then result is -1. That result -1. So we already got 1. And then I push back the index to the stack. So I put the index. This is the, for this is the 0 index. I push back that to the stack. So that's what I did. And then now this for loops comes here. So in this for loop I'm checking, okay, stack length not 0. Of course this is not 0 because I already put index of 3, that means 0 in a stack. So I already put that. Now I will get the top element. So top element is 0, or top index, we say the top index is 0 because we put the 0 index in the stack. Now I'm checking with that index. I'm checking what is the value of that index. So that index is 3. That is 3. And now the I is 1 here because the first time we put that value in a stack, and now I is 2. Now I got the item 3 and this is 2. Now I'm checking if the top index less than AI. This 3 is less than AI. No, it's not less than. So if it is not less than, then I will remove the item. So 3, so I will remove the item from the stack. So 3 got removed. Now again it will so that got removed, and the for loop is done because there's a stack is empty, and will come here. If a stack is empty, then I'll put the result -1. Then again the -1 will be stored, and I push back this index 1 index in a stack. So now we are at 4 in a loop, and then we'll come to this place again. Stack is not empty. It's not empty because there is already an index for this 2, that is 1. I get the top index, so top index is 1, and top index is 1. And then here I check if top index 1 at 1 index, that's a 2 less than 4. Yes, 2 less than 4. If it is less than 4, then I will add that index to result. So result I and the top index, and top index is 1, and that's why in the left I added 1 to the result, and I push back the item that's index for this to a stack again. So in this way I get -1 and this 1 here. Similar way, if I want to calculate the next smallest element, then I copy everything. So whatever is here, I copy everything in another function, and I will change this loop, and instead of iterating from the beginning, I will iterate from the end, greater than equal to 0, minus, and every logic will be same here except this one. If stack length is 0, then I'll put the length of array itself. So we'll see the logic here. Next, the smallest element, exactly same, starting from the end, I greater than equal to 0, I minus. This logic is exactly same. I just made a change here. Result I is length of A. So that's all. So in this way we calculated this one, previous smallest element and the next smallest element. Now we are going to find the max area. So if you see that function, max area function, there's one iteration, and the area is right I minus left I minus 1 into AI, and the result will be max of area result. So that's the algorithm we have used here. So this problem has, little bit to remember this kind of logic. Using the stack, we need to find out left and the right, like left smallest element, right smallest element, and then it will be easy. Let's see the Java solutions. The same logics I have put here. Maybe the variable name will be changed or almost same. Yeah, I just put the same. Previous smallest, next smallest element, and then find max area. And this is the function for previous smallest element, and this is the function for next smallest element, and this is the function for find max area. Okay, so yeah, that's all for now. Thank you.